Okay class, today we'll use ANSYS to work on fluid problem, and the problem is external flow. So last lecture we worked on internal flow, this time we work on external flow. For this one is a truck, we have a truck and we'll study the airflow passing through a truck. The airflow has speed of 40 km per hour, temperature 25 Celsius degree. The problem is to determine the airflow pattern in terms of pressure and velocity. Okay, now with the information, we go to Workbench ANSYS. We'll use CFX, Fluid Flow Analysis, for the project, and we'll double click geometry to go into the geometry creation. So for the geometry, what we'll do is we'll draw the truck and then we put a box, simulation box, over the truck. And inside of the box, that will be air, and the geometry truck will provide a boundary condition for the air. Okay, now it's space claim options. We'll do the first thing, check the unit. The unit we want to use is meter, minor degree 0.1 meter. Click OK, select new sketch plane, XY plane, and plan view where we'll draw the truck. So we'll use rectangle to draw the truck body, 3 by 2. Okay, so let's put 3 by 2. Okay, escape. And then we use a line to draw the front of the truck, 0.1, and then up 0.1, and then come back 0.1. Okay, and then we'll use a circle to draw the front wheel, to use Cartesian dimension to help us locate the center of the wheel, and then draw the wheel with the diameter 0.8. Okay, one more. So this is the rear wheel, Cartesian dimension located by 0.6, the center, and then 0.8. Enter. Escape. And then use this trim to trim down this part, and then also trim down this part, trim down this part. Okay, and then I will put a round corner for the truck. So let's find the round corner. Create a rounded corner. One side, the other side with a radius is a 0.5 for this one. Let's go to 0.5. Okay, 0.5. One more. This is a 0.2. Okay, now we have this truck 2D dimension, and then we'll pull it up into 3D. Click pull, move around, and then we'll pull up to the width is 0.6 meter, but we first use 0.8, the half of the truck. The reason we do that is to we'll use the mirror image to image the other half, so to reduce the drawing effort. Okay, next step is to draw the wheel. So what we'll do is draw the wheel is we'll use this half circle to pull into a wheel. To do that, I don't want the wheel and the body form the same solid, because I want to draw them separately. So when we draw it, so there are two options you need to do is no merge, so it will not merge to the main body. The reason we do it in no merge is we'll show you later. Okay, so why we use no merge, but let's do it first. Is a 0.2 width, 0.2 width. Okay, and then one more thing, click on it, 0.2. Okay, the reason we put it no, double click that, we put it no merge because we want to get separated solid, and this way that we can first use the bottom as a mirror. So click a mirror, use the bottom, And then when you click on this wheel, because this wheel is separated from the body, so it will only image half wheel. 1, 2. So now we have 2 wheels. Okay, so after that, and this is half of the truck. So we'll choose another mirror again. We click a mirror, and we use this surface, the other side of the surface as a mirror, and then I will click this body, one wheel and 2 wheel. So now we get this truck. Okay, and with all that, what I do is I will combine all the solid into back to 1. So okay, click. Oops, this error. So combine this. Okay, combine. Okay, so use combine all them back to 1 solid. So this solid will become the boundary condition for the airflow. Okay, escape in the selection mode. And because to limit the simulation size, we want to put a box on it. So to use prepare and then click enclosure, and then click on this solid body. So you will see that it will allow us to use the truck as a center to put the dimension for the box. So here check off the symmetric dimensions because we want to define differently for on different direction. So here we'll put 3 meter for front, 3 meter for back, on top 1.5 meter on top. On bottom we want to put 0 so that the truck will be on ground. But so we put 0. But in order to leave some cushion value for mesh or geometry creation, we don't put 0, because once you put 0, they will report an error, say that the cushion value should be used. So I will use a very small number. Let's use 10 to minus 6 value. Okay, and then on the 2 sides we use 1 on 1 meter. Okay, after that, go here to check the complete. What was that? An error occurred while creating an enclosure. The select body could not be subtracted from the enclosure body. Again, so for this number, we should make it a little bit larger. Let's say 10 to minus 5. See what happened. Okay, now this time it works. Okay, so now we have this. The next step is to suppress the solid. Right click solid, suppress for solid, because solid is not what we want to study. So what we really want to study is the air inside the box, and the solid will only serve as a boundary condition for the air. Okay, well, with this defined, click close it, and then right click on, no, we have geometry, and then double click on mesh. Double click on mesh to open the mesh, the mesher to generate a mesh for the problem. For the mesh, the first step is go to, once it's loaded, go to the geometry, select the box region, and to assign material for it. The material is fluid. So there are 2 options for the material, and one is fluid, one is solid. So and then click on, and the enclosure area, the details, go to the material, fluid, solid, we choose it is fluid. So click on mesh, right click, generate mesh. We can use default value. Okay, that's a mesh we have. So you can see that the refined mesh region, that is 4 wheels. Okay, looks good. And we can close it. Okay, if you look at the mesh, it's not shown as completed, so you can right click, update. Once it's checked, then we can proceed to next step, setup. Okay, and then go to setup, where we will assign boundary condition and the material for the fluid. Setup, where we assign material and boundary condition. So let's go to an analysis type, or double click on analysis type. And there are 3 options actually. So steady flow and transient flow. So we want steady flow, so we can apply. Okay. Double click on default domain, where you can assign fluid type. So by default is air and 25 Celsius degree. That's what we want. Okay, so the reference pressure, atmospheric pressure, good. And okay. Now this material has been assigned, and steady status flow. Next step is apply boundary condition. So you can right click on default domain, insert boundary condition. First we set inlet. Okay, for the inlet, boundary type is inlet, good, that's what we want. And the location, see, in the geometry creator, we didn't group them into the boundary condition we want to name. So now then we need manually to assign them. So if you click through it, and each number represent a boundary. So for the inlet, what we really need is to the front. So that's what we want to assign inlet. So the location has been assigned. The boundary details, go to the boundary details, we assign speed. Speed is 40 kilometer per hour. So you need to change the unit. It's kilometer per hour, 40. Apply. Okay. Flow, there's inlet flow. Okay. One more boundary condition. Outlet. Click OK. Then location is the rear part. It should be somewhere at the bottom. Yeah, here we go. We get it. Click OK. See, it has been shown. The mesh has been shown here. That's where we want to assign outlet. Okay. Boundary details. We need to assign the pressure at the rear. So it's 0 as the outlet. The relative pressure 0 means the atmospheric pressure. Click OK. Insert another boundary condition. Let's use opening. We name it as opening. And the boundary type we set as opening. And the location, we can manually assign the location there. So the location will be the box, the side box 1. Not this part. Control click, not on the ground. On the ground there will be wall, it's not open. Not this part either. This part and this part. So click OK. You can see around it. You will see that 3 openings, and the boundary condition relative pressure is also 0. Okay. Again, this is the opening, the location, and then boundary details set at 0. Okay, so apply. OK. One more boundary condition. So insert boundary condition. The rest of the boundary condition is the walls. That's the truck and also the ground. Okay, click OK. And then boundary type is a wall. That's good. And the boundary include from top, shift click from top to this one, 31.96. This is the whole truck. And then we need to put one more boundary condition, that's the ground. Okay, so let's control select again, find the ground. This is the ground. And now we have all of them. Click OK. Right, this is a wall. And we'll go to the boundary details. No slip wall, that's good. Wall velocity, that's 0, so you don't need a sign. And select OK. Now we have all boundary conditions. The next step will go to the calculation. We'll close it. And go to solution, double click on solution. Once it's opened, start run, it will solve it. Okay, you will see that this figure shows the converging process. The relative error will become smaller and smaller until it reaches a plateau. The criteria reached, which will be very small value, and then the calculation will complete. Okay, I said that the calculation has completed normally, and then we can click OK, exit from solver, and then finally we check the result. Double click on result, and we can add the information we want to show. So here we can look at the velocity, pressure, and all the information we want to look. Right, the where to add the output is use location and plot. So here I will insert. Let's look at the overall streamline in the whole simulation box. I'll use a 3D streamline, and I'll use all domain. Start from inlet, and then apply. So that's all the streamline. We put more point to it. Let's use 100 and then apply. Okay, it will show the streamline of the flow after calculation. Okay, to make it the result show clearly, and what we can do is we can insert a plane first. Insert a plane to it, and we'll show the velocity and pressure on the plane. Okay, so what we'll do is we'll check out this stream we just showed, and now we have a plane apply, and this plane is assigned on the one side of the truck. We want to move to the center, so we know the center is 0.8, so we can input the number, apply. Now the plane here will show the result on this plane. Okay, so on this plane, we can show its velocity. So we show its velocity. We use a streamline to show its velocity. Let's look at that. The streamline 2, and streamline will be surface streamline because we'll put the surface on plane 1. The point we can use 60, And the variable velocity, yes. And there are other options. Okay, for this streamline only for velocity, yes. So we can apply. Now you can see the streamline, and you will see that there's a pressure, very large stagnation pressure as an edge, and there is a vortex behind the truck. Okay, so we can put more information there. So, for example, we can put pressures to represent pressures. Contour is a good way. So, domain, the location we can put on wall. Okay, put pressure on walls. Remember, wall includes the truck and also include the ground. So variable, yeah, there's many options you can do, but we will choose pressure. At the contour, let's use 60 again. Apply. All right, that's what you can see. Okay, and to make it look better, you can check out this plane, and that's what it will look like. You can see the pressure on truck on the ground, and you can see the streamline in the middle of the truck, which represents velocity. Okay, now that's all we have for this lecture, and we'll stop here.